Let's start our class. Okay, first of all, okay, on the assignment 2 submission, so far I've received 20 submission. I think it's complete, right? Almost all the groups have submitted, right? 20 groups. Previously, for assignment 1, it was also 20 groups, huh? So should be complete. Thank you for your submission. And this is also the third time I think we are having a class on the public holiday. Today is again another Monday public holiday in Malaysia, right, where we have our king's birthday. Today is a king's birthday for Malaysia. But I think most of you are fine, right? So thank you for participating in the class, right? Thank you. And let's look at our agenda for today. Right, this afternoon, right, we are going to move into adding feature to our app, right? If you know about feature, right, we need to have storage, or we call it data persistence. Right, data persistence. Data need to be persisted in the system so that when you close the app, next time when you open the app again, the data is still there. Previously, our week 1 to week 10 class, we did mostly the view, right? That was the view for the past 10 weeks. And now we are adding some back-end feature to the app, right? So back-end feature, one of the most important feature that normally we have is CRUD, right? You can create, you can read, you can update, and you can delete data from a database, right? Depends on your application. Most of the time we have to create and also read, right? Sometimes you have an update feature, sometimes you don't have. Certain feature you have update, certain feature you only allow people to read, and also maybe to create, to create the data, the information for the first time, and then after that you read, right? You never allow user to update. But some feature you allow people to update and also delete, right? Delete is seldom, right? Seldom happens for front-end user unless it is the admin or some other reason, right? Then you allow user to delete the data. So in order to do data storage, right, to enable CRUD, right, create, read, and update, delete, you need to have some mechanism, a storage place for your data to be stored. So in Android, there are two ways to store data. One is to store it locally, and then another one is to store it remotely. I think most of the app nowadays are actually storing data remotely, right? That is accessible via the internet, right? So normally it is made available by a API, API, and nowadays mostly are actually JSON data, pass data between server and the client using JSON, right? REST API. So in Android, we are going to do it later, right? So a few ways to do. One is you implement your own backend, or one is you consume an API prepared by a third party, prepared by someone. Someone pass an API to you, so they give you a link, right? Basically a URL for you to access the data from the server side, from the database. Normally the data is in the format of JSON file, right? It's a text file, JSON in certain format, or XML. Right? So in Android, there are many ways to do this remotely, right? You can use retrofit, right? You can use retrofit library to actually access a REST API, or you can use volley, right? But my advice for you for your project is you just use one of the two, right? But it is more advanced to use retrofit. Actually, retrofit is a better option for you to do access to remote API. Whether you want to get or you want to post data, get, pause, or put, or delete, right? Or the HTTP. You can perform REST API runs on HTTP protocol, right? Same thing for volley, also you can do the same. Just that retrofit is a more comprehensive library that you can use. Right now, the retrofit version is retrofit 2, right, for remote access. You can also access remote server storage using a prototype Firebase. Right, Firebase by Google can be used for free. You can store data there as a real-time database on Firebase. It's called Firestore, if not mistaken. There are many ways to store, but one way is Firestore. Right, so Firebase is another option, or you implement your own server, right? Your own server using PHP, Java, and so on. For your assignment, I don't make it compulsory for you to implement a server side. You can use a remote mock API. You can mock your own API, meaning it's just a server side that mocks some REST API in certain format, right? JSON in certain format that you can use, you can consume from your app, right? So this is on the remote, right? So however, right, you can also store data locally in the phone itself. Now you can store data in the user's phone locally. So it's still backend. It's still considered backend, where your app has a front end, which is the UI, which is the user interface, which is the view. And then you interact with a database stored locally, right? When you want to store data locally, right, there are a few options also. You can store in the shared preferences. I will see whether we have time or not. Then maybe we'll try to do shared preferences next week. If not, then I have given you some sample code. If you observe on Moodle, you can find some sample code on shared preferences. It's just a file, right? That store a text file. Is a text file. Shared preferences actually make use of a text file locally, store locally in the app itself, internal to the app, with key and value pay. Right? The text file has key and value. So we can also store this afternoon. More importantly, we are going to look at Room database. Actually, Room is a SQLite. It's a wrapper class. It's a wrapper class around like, but it's more powerful than just a wrapper. It's a class, right? That is created as a architectural component. Right, Jetpack. You know Jetpack, right? It's Android X architecture component, one of the many, but this one can be integrated together with view model. Room normally is integrated with view model or MVVM architecture. We call it model, view, and view model. We are going to look at that later. So Room and MVVM, right, is a common way to common design pattern to implement database, local database, relational. This is relational database. Local relational database in Android, stored locally in SQLite. Right, the database is a SQLite database locally in the Android phone. Right, so there are other library to work with SQLite, but please don't do that. Please don't follow the old way. If you have so-called SQLite helper class, open helper class, that can also manipulate, can also do CRUD, right, with SQLite database, but there is not Room. So then that is not the new way. New way is better, more robust, where you can integrate your app, your database, Room with other components of your view, your other layer. Later we'll see how to do that, the architecture. Right, so please, you are encouraged to go for this option, where you implement your Room database, which is a wrapper around your SQLite database, with other components of architecture of the Jetpack architecture. Other components like view model, like for example DAO. Later we'll see what is DAO, and also with a repository layer. There are a few layers, so it becomes like MVC. In web, you have something called MVC, model view controller, right? So we want to separate the code. The purpose of Room database together with MVVM, the purpose is to separate the view from the model, right? And we slip in a few layers of controller layer. View model is something like a controller layer. MVC, in web design, we do web framework. We use web framework to do a website. Normally, right, the model, the data side, the data model is separated from the view, which is the HTML in the website, HTML, CSS. And then in between there are JavaScript, which take care of the program logic, right, controller. So in Android also, if you want to do that, right, you can use this to perform data storage together with a few layers of controller and also view, right, in your code. The code will be more, but you make your code more robust, easier to change, easier to add, easier to extend, right? So this is a few options to do for local data storage. One is to store data as just key value pair. You cannot store other data, just key and value. Normally they are text, integer, and so on. You can use shared preference. Second is if you want to store data as a database, relational database where you can query. This one support query. You can query using SQL-like query. So room database, or you can also store them if you want to store just video file or just document, for example, Word file, PDF file, video file, audio file, and so on. You can store files, directly store file, but we are not going to touch this because this is not directly, most likely not going to be relevant to our project, our assignment. So this one, you can learn it by yourself if your app needs to store data locally, internally, and external. Right? This is normally used to store image file, video file, audio file inside the app or outside, inside the gallery of your phone. These are all local storage. So we are going to look at this today, room database. And this is part of the topic of data persistence. Once you know how to do this, your app will have function. When you click something, you can use this to perform login, register, for example, storing data for user profile, and so on and so forth. But this is only local, right? Some of you, I think I have checked your submission assignment. Many of you have done function also, but using remote, right? That can access through a remote server using REST API. In that case, you can either use retrofit to Volley, you can implement a Firebase at the back, or some other library that can help you to connect your front end, your Android app to the server side, right? It's up to you actually. You can self-learn and implement whichever way that is more suitable for you. But I will actually touch on this because this is something new, right? And then next week or the week after, I'll touch on this retrofit, using retrofit tool, right? Okay, let's start. Right, first of all, let me brief. Just now I sent you a link, right? A link. Okay, let me close this. A link to a website on this, on the chat room, live data and view model. Right, I'm going to use this quickly. A bit of theory, before we will start on the coding. We need a bit of theory to understand it. So I won't go into too much of the theory. You can read it yourself. Most important is this diagram. So we are going to organize our code into multiple components. This is component-based design, right? You write your code in different components, which they are arranged in a layer, in different layer. So normally what we do is, before we learn this, we always write everything on activity. Your activity or fragment is the class that you always put every code in, right? Your code are always in the activity, but that is not a good design, right? Because activity is a user interface. It should actually take care only of UI related event. For example, button click. For example, selection of menu. For example, rendering some view for the user to see, right? So your activity or fragment should actually take care mostly for view related purpose, right? Just to render the view, show the layout, right? Rather than take care of the data related feature function like reading database, CRUD. For example, CRUD, you want to read database, you want to input data, insert data into database, you want to update database and so on, right? That kind of code should be separated from your UI as much as possible. That's why this architecture is created for you to do that, right? So in between database, if we separate the database is a data side, the model. If we look at MVVM, the model refers to database data. So it will be in a SQLite, physically stored in a SQLite database, but there is a wrapper class around your database that is called room. There is a wrapper class. So later we are going to create the wrapper class called room database. And then we also need to execute some query. As we know, we want to do CRUD. CRUD, we need to query database read, for create, for update, for delete. So there will be an interface function, a few interface function that we define inside TAO. TAO is called data access object. Just remember, this is just a mapping of SQL query to the function that you want to execute to your database. Right? Previously, it was done using SQLite open helper. So this is just like something like a helper class like SQLite open helper. If you use that class for doing SQLite, it was the old way. And new way, we use TAO. It's just a very simple interface file that you create a few query function to your database. Whichever query function you want to perform, like select, like update, like delete, like insert. Right? This is to map SQLite query, not SQL query. And then upper than that, we do just a wrapper class to separate the view from the database we call it repository. It's just a class that pass the data, right? Pass the data and also pass the action from the UI down to the database to execute the query, to invoke the query. And also the repository layer is also intermediary between the database and the view, where it passes the data back to the UI for UI to display. Right? So repository is just a middle layer that have some function that the UI can call, and then in order to access TAO. UI cannot access TAO directly. We want to separate that. That's why we need a middle intermediary for the UI to call the function so that the function will be executed on the TAO. Right? And then above that, actually there's another layer that we add, but this is nothing to do with room. This is actually something to do with MVVM, the architecture component, where whatever data related logic, we call it controller code, data related program logic, we don't place it inside the activity or fragment. We don't want the activity or fragment to do heavy tasks on data processing. So the data processing code, we move it to view model. And if we use it's just another class, additional class. It's something like repository, but we don't call it repository, right? It's just an additional class that will attach to the controller, UI controller, attached to the activity or attached to the fragment. Additional class. It's just additional class. And inside that class, you perform the action to pre-process or post-process the data before you display on the UI. And then live data is just a kind of data type, a special kinds of data type where whenever the data is changed, right, by the database, when you retrieve data change, increase, decrease, right, you update the data. The update, because it's called life, right, the life cycle, this data type has a life cycle. So whenever the data type change, UI will be updated. So it's by asynchronous update, meaning the UI will actually listen and observe the changes on the live data. And only when there is a change in the live data, then UI will be updated. So you don't see a blank screen every time the UI is updated with a new data from database. You don't see the screen need to be loaded over and over again. So the UI can only update based on the changes, the small changes on the live data. So there is just a data type called live data. The live data can be met on top of a variable or a collection like a list or array, right? So anything can be made a live data, right? So this is the architecture that we're going to go through. Okay, so let's start with a new project this afternoon. Other than this, we are going to also do QRCode scan. As I know, many of you need to do this function QRCode scan this afternoon. Other than, okay, let me remove all the rest that is not relevant. Okay, this afternoon we are going to do this only. And then we are going to also add in QRCode scan. So we are going to add in QR code scan as a method to capture user input, right? User input based on a QR code, right? So this QR code is going to store location name of a place. Whenever you scan, you go to a shop, the shop display a QR code. So that QR code, we use a library to scan. So we scan that QR code actually represent a name, the name. It's just a string. It's actually a string. QR code is just a string. Right? Instead of writing the string, the QR code is actually a code that represents a string. So we try to use QR code scanner library to convert a QR code to a location name of a place. And then we'll store this location name into the room database as the input, right? So we call it Checkin, right? QR code Checkin. So that Checkin location name, and we attach it with a date and time of the current time and date of the computer. Then date and time plus the location name become a Checkin history. Checkin history is a list collection of all the place and the date and the time, right? So this change usually we are going to display it on the UI, display on the activity. I will use activity to make it simple. For your project, you can modify according to what you want. Display in a recycler view. We are going to use a recycler view to display the user interface, to display the check-in history, to display the list of check-in history. Okay, so let's start. Okay, we can start with a project, a new project. Let's start with a new project, QR code scanner. Okay, I have the code already, actually. I have done it, but I will do it together with you again this afternoon, right? I'm going to use Java. Actually, this is easier to use Java. If you want to use Kotlin, also I have the code already. You can refer to that. Because Kotlin, you need to know call routine. When we access database at the back, it's asynchronous. So you need to have some parallelism, right? Meaning when you submit a query to the database, you cannot wait for the database to respond before you move on, you continue, right? So there's a asynchronous there. So the way to do asynchronous is in Kotlin is to use call routine. But we don't have time to talk so much on the other concept, call routines. But I have that so-called call routine code right in the sample I already upload to Moodle. You can check if it is Kotlin version to do room using Kotlin, then you have to have some code called call routine. Call routine is just like some asynchronous function, right? But in Java, we use callback. I'm more familiar with callback method. It's easier to do, easier to understand rather than call routine. If you have time, we can use a class to talk about call routine, but we don't have time, right? Call routine involves suspend function. So this afternoon, I'm going to use Java, right? And actually the code, both sample I have, right? I have already uploaded to Moodle, right? You can check. So I'm not going to use Kotlin this afternoon in order not to spend time on the call routine. So we use the conventional method in Java using callback, callback method. Okay, so let's move to the project. Let's start with a new project. Wait. Where's my, okay, wait. Let me share. Okay, let's start with a new project. Let me start with a new project first. Do an empty project using Java. Let's call it the project, call it room. Room, this afternoon room. QR code room. So we are going to do QR code scan, and then after that the check-in. Let me bring up my screen first. I couldn't find my check. Okay, I use the full screen. All right, so we create a new project. Java. I'm going to use Java to demo. The concept is similar, the step is similar, just that easier to use Java, easier to understand the code. Okay, so we use QR code. We can call QR code check-in. QR code check-in using room. QR code check-in using room. Using room database. So room is SQLite actually, huh? QRCode check-in using room. You can name it this way, or you can name it whatever way, whatever name you want. Huh? So you store it in your the drive that you want to store it. Huh? So for me, I store it here. Okay, so finish. Right, so create a new project. Okay, so we are going to use we are going to do two different functions this afternoon. One is, as I mentioned just now, QR code scan. We'll do the input first, QR code scan, easier to do. And after that, the storage. Storage. We are going to store whatever people scan, the string into database, which is a room database. The QR code room relational database. Right? The entire thing will be later on, we can create a list in your database table, a check-in history list. So this is how we are going to do. So it's not going to be very short. It's quite long. So hopefully by 6 o'clock, we can finish this. Okay, so once your code is synced, your project, just create a new project. Even if you use Kotlin, it's fine, but Kotlin, you need to, when talking about the backend server, that database, we need to add in some code on call routing. But the one I can open up my Kotlin project later to explain to you what is the difference, the slight difference. Kotlin doesn't use callback to do a synchronous function. So they use call routing. Something new is another topic altogether. Okay, never mind. So let's move on. We use Java first. I realize many of your projects also in Java. So I use Java. Okay. First of all, we want to add our library dependency. Okay. So we need to add a QR code scanner. So if you want to know what QR code scanner, I know many of you use different QR code scanner. Right? I'm going to use ZSyn, zebra crossing. This is quite, even though it's written Java here, but it can also be used in Kotlin. I've tested that it can be used in Kotlin also. So you can use code scanner and so on, many. Actually not restricted to any of these. As long as the library that you import, Java or Kotlin, can scan, can convert a QR code into a string, then you can use that library. I'm going to use ZSyn. This is the one, zebra crossing. It's called zebra crossing. So I give you this link. You can, if you want to, haven't done that. If you haven't done that, I see many of you have done. But if you haven't done that, this afternoon, you can consider, look at the, you can follow the way I do. I use ZSyn. So my library is ZSyn. Okay, so the first thing we do is we want to add that ZSyn library into our project. Right, the ZSyn library, this one. Dependency. So I'll give you this code. Yeah, let me open another. That's the formatting. I want to remove the formatting. View the code. I don't remember code this time. I need to copy and paste a bit. Also faster this way. Okay, ZSyn. Right, this is for zebra crossing. If you want to check the documentation of this library, you can go to ZSyn scanner, QR code scanner, right? The website. This GitHub page. This ZSyn. There is sample code for you to test how they do it. But I'll do the simpler one. Simpler one. I just use one of the basic one to scan something to convert a string QR code to string. Right. So this is the GitHub page for ZSyn library. This is for QR code scanning. Remember, scanning. It's just to convert a QR code into a string. Right. String is the location of the place. Right. Can so just pass this in, and then sync later only sync. You want to sync also can, you sync first. And then we also want to add in the library for room, right? And also lifecycle component. As I said just now, right? We are going to do a multiple layer code, and the room database need to have additional library. This one is not existing in the original project that you create. Empty project doesn't have room. It's not added to dependency. And also repository doesn't need any dependency. Repository just some Java class that we create ourselves, right? It's a generic Java class. But live data and view model also need additional library dependency, right? So the blue color view model and live data need dependency. Room database, the gray color, the tau, the entity, right? Need annotation. We're going to use annotation for tau and also for entity later. So room database and also view model and live data, these three, right? The blue color and the gray color components need dependency, additional dependency. So these are the additional dependency. Huh? So you add into your database, to your grader, build.grader file, right? You can add into your build.grader file. Just add into your build.grader file, add it here. Right, and then you synchronize them. Huh? Right, once you synchronize them, fine, huh? It's done. Right, your dependency. So additional dependency are actually these three. For zebra crossing, this one has nothing to do with the MVVM, nothing to do with room. This is just a third-party library for QRCode scan. You may use another library also can. Doesn't matter. So I will use this as a demo. You can use this as for your project also if you haven't adopt any. Room database is for our SQLite, right? This is for MVVM. And then this one is also for MVVM, right? Both all these are actually part of the Jetpack new framework, right? For architecture component, we make our system to be robust in a way that we create multiple components that interact with each other. So it is actually documented in Google. Google actually created this architecture for us to follow. Right? It's easier to do if you use this. Room database, lifecycle components, which involves live data and view model. So you can see here, view model, live data. Right, and then sync them. Okay, done. Once sync, you close it. You can close it. Okay, next, we want to create, okay, we are going to go from the bottom up. So we'll start from the bottom rather than activity. We don't do anything on the activity until okay, maybe like this. We do the view first, the layout first. So what we do is the layout, we need to have we just need, I'm going to just do a very simple layout. For you, for your project, you do based on what you need, right? So our layout will have a recycler view. I'm going to do a recycler view in the layout. So what we do is I'm going to add, let's go to the main activity layout, right? The main activity layout, delete whatever text view that is there, delete, make it empty, right? Layout, empty layout. And then I'm going to create a body for the layout and then I add in a recycler view. So I name it recycler view. As simple as that. Just make it as simple as that. Right, a layout that recycler view that match the entire screen. Parent, match parent for the height and for the width. Okay, let me give you. This sample code will be there, made available on Moodle later. So for now, you just listen first. Follow actually, I think quite quick enough, fast enough for you to follow. These are just things that we have learned before, right? We have learned before, recycler view. Right? I'm also going to add a floating action button. So I just get the sample floating action button code, right, from the Google developer documentation. I'm going to use a floating action button to trigger the scan. But in your app, you may not use a floating action button. You use other kinds of button. You let the user click on something, tap on something, make it maybe an image view, image button, or conventional button, or maybe your what is that? The day we do the floating action button on the bottom navigation view. Right? We did the project a few weeks ago. Bottom navigation button, in the middle, we have a floating action button. You can also use that. But for this afternoon, I'm going to use a simple floating action button to trigger the scan, trigger the scan event. So I'm going to just put in the floating action button. Simple one. Right, I call it fat. Okay, the icon, right? I don't have the icon. I think I just put a text there and put it as plus. The string submit, I just hard code, submit. Or no need, no description. Okay, let me see why is it so. Oh, okay, the constraint, This is constraint layout, right? So I need to add in constraint. Right, so if you never add in constraint, you collapse, right? So I need to drag to the left, drag it to the bottom, right? And then here, right? So drag it, just drag it. So I make it simple, UI, the view is not our main target this afternoon. So basically just constrain it to the bottom of the parent and the end on the right hand side with a bit of margin, adding a bit of margin, so that it's not stick to the border. So it's something like this, I make it simple. Later we click on this, then we trigger the QR code scanner, and the recycler view will be in the background, cover the entire screen. Okay, so I give you this code. No, you just follow lah. This is just a simple view, for us for demo purpose. Okay, let me see whether I can check. Okay, this is our activity underscore main layout, right? Just a simple layout, to do a quick demo to understand how it is done. So there's a floating action button, right? It's under the material design library that is already included in the original project. When we first created an empty project, we have already have this material design dependency done. Dependency is there. So what we do is we have done the layout, recycler view and floating action button, a simple layout like this. Okay, so the view side, the activity side, we leave it now. Done already. We don't do anything on the activity code yet. Just close it, close it. The view is done. The view is done. So we move back to the database side. Let's move back again. Let me close whatever not relevant. Let me close. Okay, so we want to now move to this database, room database, the one at the bottom, very bottom here. Right, the room database, and then we do the tau. So for room database, we need to create a data model to represent our data set. We call it entity, E-N-T-I-T-Y, entity first. Just a Java Pojo class. You know what is a Pojo class? Entity is just a Pojo class. Java Java class, a very generic Java class. They have all the getter, setter, and also the constructor done. To represent an object, right? With a constructor, with the getter function, setter function, right? And the properties of that class. So entity. So we call it history. Because we are going to store data as a check-in history. So I call it history, history class. So what we do is we go to the project here, right-click, new Java class, new Java class. We call it history, capital letter, H, right? Java class, history, right? Pojo, we call it, normally this is called Pojo class. Java, I can't remember what is Pojo, Java object. Let me see, just for your knowledge. We call it Java. Pojo stands for plan all Java object. Plan all, PO, plan all Java object, Pojo. We create a Pojo class, plan all Java object. Okay, so to make it fast, I have to show you what is supposed to store. We are going to store a simple Pojo class with location and name and date. You can make more. You can actually add more property, but for demo, I just show you the basic. You want to have a scan, QR code scan. Supposedly, you can also have a time, right? Doesn't matter, you have time. I use time and date is similar, just add additional field. We are going to use location, date, and maybe an ID as a primary key for your database. Later, when we generate the database table that is going to be generated, database table will follow your Pojo class, right? Your project class define the structure of your database table. If you have ID as a primary key, then it's a column for ID, column for location, column for date. Understand? So the project class will mirror the database table, which is a relational database table. Your project is in the code, and then the database table is relational database, is a table. So whatever field, whatever property you define your project class will be created as a table in your database, in your room database, SQLite database. Okay, let's just add in first, right? Later we need to add a notation. For room, we need a notation to represent that, so that the framework knows actually which are your field for primary key and so on, right? So for now, we just create first. So we have an integer, which is ID, right? Relational database, we have an ID as a primary key, and then we have something called string to represent the location name. You can call it location name, or you call it location, easier. You can also have something called date. We use a string to represent our date because we just want to display and store, right? So you can later, when you process your date, you want to sort and so on, you can convert the string to a date format that is supported by the Java utility, right? But for now, to make it easier, convenient, we just use a date, a string to represent the date, to store the date. Okay, so 3. Right, so what we need to do now is, for the history class, we need to annotate it so that the framework, just now we import the framework, right? We import the room framework, this one, the room framework, the room runtime, the room compiler, so that the framework knows what you are actually trying to do with this history, right? The database. So what we do is we need to annotate so-called entity. So once you put it as entity, this is a table name. You can name it any name you want, a valid name, but I call it, the table name is called history table. Later in the database, you can see a table called history table. So this entity is this entity in the diagram. You see or not, the gray color entity. So you can have more than one table, but our case, we only need one table for this case. So we need one table, history table, entity, right? So we create the entity first. The view we have done just now, the layout. Now we are going from the bottom up, bottom from the down bay, bottom. So we create the entity first. This is called a notation. So you actually import, you see, room, Jetpack, right? Android X, Jetpack, room database, class, room class, and then entity. You need to import. Once you pass it into your project, then you'll see the import to happen. And then this one, the integer, right? We make it primary key, right? The annotation is primary key. So we make it auto-generate, meaning the database, you don't have to store a ID to the database. Every time we insert a new location, the ID will be incremented 1, 1, 1, from 1 to 2, 2 to 3, 3 to 4. So you don't have to worry. It's something like relational database. You make the primary key auto-incremented, auto-generated, auto-incremented. Okay, so let me give you this very brief project class. Project class, right? The project class. So what project class, right? We need to also do the getter setter function. Each of these location and date, right? We should allow it to be accessed via a function. So we make it private. For all the property, we make it private. So make it private. So that we need a public function to get and set the location. This is a right so-called principle when we define a class, right? So we make it public class, and then ID we have to be public, and later we need the other function to access it, right? To auto increment. So the rest private. Okay, so we have to have a constructor for this. So what the constructor do is very simple. It's just to initiate initialize the location and the date, right? So we pass in a location. When we construct it, we pass in the value of the location and the date. Then we initialize it. Let's initialize it to the value passing. So this is a constructor for this history class. Just construct. And then we need some getter function for location, right? Get. So get meaning get the string back, right, from the location, right? So automatic POJO class, the Android Studio will create this, will allow you to have get location by default. Okay, so you return the location, the value of this, get the location. Then set, right, is the opposite. You want to set the value of the location, right? You see, when you put set, you actually generate, show you that, I can't go. Location, right? You pass in a value to set. So what happens is you can change the value of the location by calling this function. Calling this function, set location. Get, set. And then for date, date also same thing, repeat. Just repeat the same thing, get date. Just return the date, right? Return type is string, right? This dot date. Same thing for set date, right? Set date, you don't return anything, you set, change the value. So passing a value of the date, right, that you want to change. Right? Okay, get, set, getter, setter. This is, we call it what? Another name is called mutator. Set is your mutator. Mutate the value, mutator function. Set and get. Okay, understand? So basically your Java class is to do that. Your Java class that is going to be representing the library, the library of the table, your room table, SQLite table. So let me give you this full code. Right, basically this is just a generic class, only with a difference. You can annotate with a room annotation. To say, oh, this table is actually, history is a table, it's a mapping. You are doing a mapping a class, Java class. In Kotlin is a Kotlin class to the database, SQLite table. And then the field is going to be mapped later also to the column inside the table. So the ID, we annotate it as a primary key, right? So let me give you this. Right, this is a full code for history, for history class. The entity, we have done only one entity, right? We'll create a few more before we go for a short break. Entity. Done. Okay, now the next step, we want to do the database. We do the tau first, the tau, the query, the query, right? The tau. So next, let us close this entity, Java class entity, and then we create an interface. It's not class, it's an interface. So in object-oriented programming, interface is a API, is a class that without implementation, you don't implement the function. The function doesn't have a body. The function only have the function name, or so-called the function prototype. Now there is an interface. So we are going to create an interface. We call it history tau. Tau, DAO. Just now I said DAO stands for data access object. Tau, DAO. Or you can put capital letter DAO also can, or capital D and then small letter AO also can. It's just a name. Tau, data access object. It's just a query. So SQL query. We define map the Java function to SQL query. So we call it history tau. History, capital D, small letter AO. History tau. Okay, enter. Right, history tau. Right, so for QRCode scan, right? So CRUD, right? Do we need to update? We don't allow user to update the check-in history, right? the user cannot update, right? Once you check in, it's in the server, in the database side, in the back end. So it shouldn't be outdated. The check-in history shouldn't be manipulated by user. Also, you cannot delete. You shouldn't allow user to delete. So the user app, the mobile app shouldn't be able to delete the record at the check-in. So there is only two things that you need to do. One is create, which is to insert. And then one is to read, which is to retrieve. In database, we call it select. We only want to do this for our purpose. For check-in history, is just insert, which is to add a new record, check-in record into the database, room database, and to read is to select, right? Only the two, right? You don't allow people to delete. If you want, you can define also, doesn't matter, but you don't need to implement it, so you leave it. So you just do this two, insert. Okay, how to insert? Let me close. Insert is just to query, right? Insert. This one, insert. So in tile, right? In library, in room, you also need to have the so-called the annotation for tile, right? Annotation for, first of all, we need to define this tile as an interface. Just put an annotation here, there. Insert, import this room.tile DAO. Alias. So you make this interface to be a tile interface. Without this, the framework, the room framework doesn't know what is history tile, right? So you annotate, you tell the compiler later, when you build the code, this is to build it into an interface to access the database, the room database. Put an annotation, tile. And then we also put for insert, we need to put an annotation called query. Not query. Or insert, sorry, insert is not query. Insert is insert. Insert. So you just move. This is just an annotation. Annotation. The code doesn't execute, but the code will actually tell the compiler something, right? So actually it's a function. We map it to a function, right? The function is called, we call it insert history. You can call it any name. We call it insert. Insert a history object, right? So what happens is this function. This is just an interface. It's not a function because it's an interface, right? There is no implementation. You see, no implementation, no body. There is no body to this function. This function doesn't have a body. You don't need to define a body. So don't define the body. So just put semicolon straight away. So this function insert, later you are going to use, this function is going to be called from the interface, from the activity or layer above. Not the activity, but layer above, which is repository. Just now you see, right? Repository. Okay, let me close this. Repository here, right? Repository layer. You see the arrow point to tile. So later we are going to create a Java class called repository. Inside there will be also a function called insert. That insert is an intermediary wrapper function that call the tile insert. You execute the insert in the tile. So what happens is this tile doesn't have implementation, right? It's just an interface. So you are going to pass in a history object, which is your table record, right? A record with these three fields, ID, location, date. But when we construct the ID is auto-generated, auto-incremented, so you don't have to pass the value of ID. You basically just need to pass, when you construct a new history object, just need to pass in location and also date as a string, right? So this is how you call it, right? The entire object, you just insert it into the database, you create a new record, right? So read, okay, this one we need annotation using query. Query. Read is select segment, select segment, right? Query. So what is the query that you want to query? Select, right? Everything, right? SQL from just now the table name. Remember the table name? History table, right? History table. So select everything from history table. And then here you need to define a function. So the function you need to select and then return, right? Return a list, right? Return a list. So what we do is we need to return something like a list, right? A list object, right? Type is history. In the list, every object, every item is history. Every item is a history object. And then we make it to be a live data. Just now I said the history list will be updated, right? Database, every time we insert a new record, the list will be updated with a new record. So that new record, we want to trigger the UI, the view, to update the view, the recycler view. On the view, the list will be seen as a recycler view. So later we want to trigger the recycler view to update. Then we need to make this to be live data. The list to be a live data. It's just, you just use a bracket, the greater than, less than, to make it to be a type of live data. Generic list is like this. The list of history. So what we do is just make it to be a live data. So what we do is we just add this function. This function is a mapping to this query. So for this query, if you want to sort the history with the ID, right? Just now your ID, right? We want to see the latest one on top, right? You can actually make your query to do sorting, right? Sort by, what is that? If not mistaken, the SQL is order by, order by. Descending order, order by ID, descending order. ID is actually the value, increment 1, 2, 3, 4, 5. So if you sort in descending order, the latest one will be on top. When your recycler view is shown, you want to show the latest one on top, right? So this function is mapped to this query. When somebody call this history, try to call the interface function get all history, actually in the back end, the database will actually execute this query. Or execute this query. So okay, this update and delete, we are not going to define it, but if you want to do it also can, right? It's just a matter of mapping it to the function. So delete. Let's say we want to delete, update no need, delete. Let's say you want to delete the entire table. Very dangerous, right? Delete from table. We need this also, right? Later we want to create a new database table. So we need to delete everything in the database table. Delete all the record from the database table, history table. And we map it to a function called delete all. Delete all. Right? So this one no need. We have 3 functions here. Delete all, get all history, and insert. So this is our tau. Right? Our tau. Data access object. Okay, let me give you this. This is to be put into your tau interface. Just now we created this so-called tau interface. History tau. Right? History tau. Right, so I hope you understand. So we do one by one, step by step. So in the room database, there are one more component. So once we have done that room database, now we still haven't done the actual engine of the database. We have done the entity to represent the table schema. So entity is actually the table schema. This is just put to represent the database table schema. It's only the schema, the format of your database table, the column name, location date, right? And then the tau is the interface function. It's just an interface, nothing. It doesn't do anything. It's just a mapping between certain query and certain function, right? But now we want to do the actual engine, actual engine of the room database. So what we do is we create a new class called history room database. This one has some code that you need to understand. Using Java is easier. If you use what is that? Call routine. Using Kotlin is a bit difficult to understand the code. But now I'm going to use Java. Java. So history room database. Okay, let's create a new class. Java class. Java class. We call it history room. It's a room database, so we call it room database easier. And this room database is for history. That's why we add the history in front to represent it. History room database. It's a class. So this history room database on this diagram, always remember this diagram. Is actually the room database, not the engine, the gray color part that encircle the entire tile and entity. It's a class, the engine, the actual engine that manage the database. Okay, let me give you this diagram. I pass it to your chat. You can keep a copy of this. Always when you want to write this code, you always need to refer to that chart so that you understand what you are doing, right? You understand what you're doing. Room database now. Right, room database. So this room database, you also need to annotate. Otherwise, the room framework doesn't know what is it. So you need to annotate it with a database tag. Annotation, database annotation. It's an Android X room database. Right? Okay, annotate it first to tell that this class actually is the database class. Right? Okay, so you need to put in some attributes. This one I just quickly just show it. Put it here. First of all, you need to tell what is the entity class, right? This is the entity class. Just now, right? History. So for this database, you take care of just one class. In real project, you may have many class, many table. Just now we only do one table, right? For this example, we only have one table. But in real case where your room database has more than one table, you need to list. It's a entities. The attribute is a plural. So it's a list. So you need to comma, let's say you have user dot class or something like that. So you need to define multiple of your table. But for this case, only one table, history table. Dot class is a class. Version 1, we assume this is the first time. So when people first time install, this database schema will install into the app as a first version, right? Let's say you test, right? You want to recreate the app again. Either you uninstall, you need to uninstall the app and then add in the install the app again, version 1. Else, this version has to be incremented every time the database change the updated the schema. So this version can be 2. Let's say this is for you to control your app version. Let's say the database you release your app already, then people use it, and then suddenly you want to add a table or something like that. Then you should change the version to 2, and then before you compile, build it into another app and distribute your app to your user, so that when they install, the all database will be deleted, will be removed, and reinstalled with a new database with a new schema. So this is to control that version of your database. And then export schema false. We just don't export the schema. Make it false by default. Okay, so this is the annotation. First, you must do an annotation of your database. Okay, give me a while. I finish this one. I'll give you a short break. All right. Okay. Now, a few things to do, right? In this history database, we will make it abstract class. You extend the room database framework. So it's not a generic database class. Java class is actually extend room database. You extend the room database. So what we do is here we extend a room database, and also make it abstract. That's some function we don't implement it in this class. We implement it in the class that actually inherit this history room database, abstract class. Extend room database is a library that we import, right? Android X library, room database, and then we make it abstract. Okay, now we need to define a few things. All right, we want to create an instance. Singleton database shouldn't have more than one instance, right? For one app, you should run on one, at most one so-called database instance, meaning in the memory you should have one. You shouldn't have more than one database happening. You can have multiple table, one database, multiple table, but not multiple database at the same time in the runtime. So we create a static instance, so you create only one instance later. right? Private static history database, room database. This one, we create an instance of the database, not just one, right? So private static, the room database, right? Instance. This is just a variable. We put it capital instance. Okay, what happens is that instance, we are going to do a singleton. Singleton meaning the database is only can only be instantiated one time. So we put in some checking. If it is now, if the instance is not instantiated yet, so we will instantiate it. We'll create it one time. If it is already created, then this one will be skipped. We just return the instance object straight away. Whenever the history room database is being constructed, get instance is a constructor. You construct the room database. First time you construct, you check whether the instance is already alive or not. If the instance is already not now meaning alive already, then you don't do this. You straight away return that instance. If not, if it is still now, meaning not created yet, you create it with a so-called synchronize. This is the place where in Kotlin you need to use something like coroutine. But for now, we just use a synchronize so-called function. Right, the code here, right, will be created right in the back end. So you have created a database file in the app. It's like SQLite. This part is actually creating an SQLite database in the app. We name it history.db. So let's just follow this code, right? This is just a singleton function. Make a function get instance that create the database in a singleton design pattern. So what we do is we declare this, right? Instance, and then we create it. So this one later, the callback, because as I said just now, in Java we can use callback, but in Kotlin we use coroutine. So this afternoon I use Java so that you can see later we define a callback function to create the database. Right? We can create a pre-populate the database table with some record. Right? So it's a callback. Using a callback, add a callback function to do that. So I give you this part. Right inside your history database, I give you this entire part. Right, so this is a room database that we are going to create whenever the app is booted out first time. Create the database only one time. Only if the instance is still not created, it's still now. Right, this one we define later. Okay, so this is a singleton. Singleton 只是一个 memory. In the memory, it only happen one time. One object of this instance. Only one time. Okay, then we also need to define a callback. Right, callback. Callback method meaning asynchronously the database will be created, so the app would not be blocked. We don't want the app to be blocked and waiting for the database to be created. This database creation process will take a while, maybe not too long, maybe a few milliseconds. Right, so that millisecond we don't want the database to block the app. Right, the app will be freeze. So we need to have a callback method, a synchronous method to actually execute the function that we use to create the database. So what we do is we define a callback method. Right, just follow this code. Don't worry too much about this. I'll explain it. So here, right after the singleton, what we do is we actually define this callback method. Right, callback. This is just a name. You can make it shorten. You can shorten it. Room callback. Or whatever name, so you just change it, room callback, make it shorten. Right, so we create a callback method to create that room database. This callback, right, is part of the room database framework when you inherit. Right, we inherit here. So there's this callback function available in the room framework. So what happened is you need to define some write executor. This database write executor, right here. Right, you want to use this executor service, which is a back-end service. Background service. So this background service will run parallel. It's not part of your UI thread. You don't want to execute the database code, database creation code inside the UI track. In any app, we always have a UI track that take care of the UI. User will interact with the UI based on that UI track. The activity, activity have a life cycle. So activity fragment, they are running on the UI track. And you want to do this on the background track. And another track there is called executor service. So this is done using a background track. We call it executor service. Like Java, executor, this is in Java, executor service. So we use an executor service to execute a background track that create the database. I hope you understand that. So that it doesn't block your UI, it doesn't run on the UI track. So what happens is you need to, okay, you also want to define how many parallel track that you can run. This one doesn't matter. We just create 4. But our case only need 2 actually. We just create 1 database. But we can add more track. So meaning in the background you have 4. At maximum 4 background track that the executor service can run. But in this case, you create a fixed track pool of 4 background track. But only 1 is needed in this case to create this database and populate the database. You can make it 2 or something like that. 1 also can. Okay, so we make 4, 4, but it's not used. The track is not used. So only 1 is used. So here, we actually create a, this is just a constant to define how many here. You can put 3, you can put 4, you can put 1, you can, right? So just to show you, you can do multiple track at the back end. This is a background track. So I give you this. So you just declare them. Just declare them. I give you this code. You just declare, declare. Declare on top. Right? And then this executor service database write, we call it, this is just a name variable we give it called database write executor. And this database write executor, right, is going to execute. Right? And then what does it execute? This is to pre-populate. This part, you may not need to do this at all. You can put 0 also can. But we want some dummy data. We want to put some dummy in the beginning. The database is not empty. If you want to pre-populate the database with table with some dummy. Just now I say already, right? You can use tau. The instance will call the history tau. Okay, this one is not defined yet. That's why we need to define. We need to declare it. It's not declared. So we need to declare it. So this one, you declare the history tau. History tau is actually our interface that we created. It's abstract, right? Because it's an interface. Right? So we just declare it first. So what happens is we go to our code here. Abstract history tau, right? Is this one history tau just now, right? History tau. It's an interface. So it's abstract. Interface means abstract. There is no body. So we just declare, right, a history tau, right? Construct a history tau. And this is used to access your history tau mapper. The map just now tau, right? This we declare a history tau object. This tau will call the method inside history tau. Like first of all, just now I said delete all, right? We delete the clean. This one clean the table. If there is some data, first time, this is only first time when you install the app. We delete the table and create a new empty table. And after that, we insert. Just now I said history, insert, right? We create a new history object. Just put some dummy data. This one is just some dummy data. The first parameter of the history entity is the location. Right? History object, location, when you construct the history object. Second parameter is date. So what happened here? We just construct a new history object. Right? New history object. First parameter location, second parameter date. As simple as that. And then you insert using the tau to insert into database. Pass the object to this insert function. Right? You delete first and then you insert a new one. So your database will always have at least one the dummy with this value later. Now this is just for testing. You can actually do without this also can. Do without this also can. Just for later you can see. By default there will be one location and one date for the check-in history. Just for testing, for this purpose. Okay, history tile using tile. Right, this is complete already. So complete already our. Okay, this one may not be used, but it's okay also. You can add in a function just to delete this instance. In case your app running halfway, then you need to, but it's not used. In our case, we don't need to use. But you can also define a function to delete the singleton. We have a singleton object, right? We get instance, we can also delete the instance. You can destroy, we call it destroy instance, right? Just make it now. In case you need a function to just remove the instance from the memory, the database. You want to reset, reboot the database. So you need a function to make it now, in case. But it's in our example this afternoon, we don't need to use. But you can define, you can prepare one, right? Destroy instance. Right, so done. This is a full set of code for your room database, which mainly will be create the instance. And then after that, with the instance created, use that instance to create a database table with some dummy data. I'll use the instance that is created just now, call the tile to insert. Delete first and then insert a dummy record into the database. The purpose of this code. Okay, let me give you this in a context. Easier. This is too long, a bit long. Let me give you in the context. Okay, this is for full code for room database code, right? Room database code. This is for our class, right? Class called history room database. History room database, right? Okay, for the last 1.5 hours, we have done about 50% of all that we need to do. Set up the backend, and then later we are going to do the intermediary layer and then do the view model and do the recycler view. On the activity, we need to do a view holder. Recycler view we have done already. We know how to do, right? Using view holder, using the so-called what is that? The view holder. Sorry, not view holder. Yeah, view holder. Sorry, view holder and the adapter. Yeah, what is that? List adapter, if not mistaken. Recycler view adapter. We need an adapter and the view holder to construct the recycler view. So those are the code that we are going to do later for the view, for the front end, not the front. Okay, now the back. Okay, so normally when we organize the code, I think some of your project I saw that also. You can organize this code, these three: history entity, history tile, and history room database as one directory, right? A directory. If you want to organize these three, entity, tile, and also the room database, you can organize it as a directory. So here you can create a directory, new directory, or package. We call it package. You can call DB or database. I call it DB. So you can move all this into a DB database package. Refactor. This is called refactoring the code. We can actually put them all in one folder. So that is more organized. The database related code are all under one directory, one package. Okay. Right. So you can create a folder and then move them in. All right, so it will be refactor automatically for you. Right, you add in the namespace, the path, right? .db, right? If you put db as your package name. All right, so far so good. Oh, we have another 1.5 hours to complete the rest. Okay, let me just give you this half done code first, right? And then we go for a short break of 5 minutes. All right, give you the code first, half done, so that you can follow. If you don't manage to follow, then you can follow. So I give you this code. Right, so I give you now. So if you don't manage to follow, you can follow this. Right, so have done. You cannot run yet. It doesn't work. It's empty. The activity will be empty. If you run, you can run, but activity is nothing. Because we haven't done anything in the activity yet. So we have to add, right? Add additional code to the activity and the layer above the activity, the code. So we need to add all this in the next 1.5 hours. Right? If you run currently, the current code, you won't see the anything because the activity is still empty. Right, activity is still empty. Do nothing. Still doing nothing. Right. Okay, so let's have a short break of 5 minutes. And then we continue. let's continue, and so that we don't go time today. Right, we still have half of the work done. Right, I hope you understand the concept of room. Not difficult if you understand the concept. Okay, so let us recall what we did before the break just now. Right, so this is the overview. Right, so we have done the room database. Just now before the break, we have created 3 classes. Right, one is the entity called history, the entity. Right, this one, and then we have created a database class. It's an abstract class. We create the instance, right, of the database, and then we use the tau, right, this one, right, the tau query insert to insert the dummy data into the database, and we have also done, right, the tau. It's an interface only, right, map the query of SQL query to some function that we define, user defined function. This is tau. We call it history tau, just now. So now we want to do this one, right? The repository, the next one. It's a Java class. It's a generic Java class. Don't worry. It's just a wrapper class. Wrapper meaning it doesn't do anything except to call other function of the other class. Right. So now we are going to do that. Okay. First thing, we want to create the class. We are going to create in the root folder. New Java class. We call it history repository. Repository, we name it history repository to represent our project. Today we are talking about Checkin history. So it's a repository class. It's a generic repository class that is not going to have anything special except it's a repository class that is between, what are the layer between view model and also the tau. You see the arrow? The arrow, right? So it's going to be called, the function inside repository is going to be called by the view model later, and the view repository will actually pass the call. The call is a wrapper. So whatever function that other class that call it, it doesn't do anything. It just call another function inside the tau. Or you execute a function inside the tau. So it's a intermediary, as a middleman, 中间人, middleman, orang tengah in Malay, repository. So it's a middleman, it's a wrapper that actually has certain function that will actually execute, call other function inside the tau, tau class. All right, so let's start. Okay, so just now in the tau, what are the functions? The 3, right? Insert, get, get everything, list, get all the record, get, insert, and delete. So these 3. Basically, what repository needs to do is also that 3. Actually, that 3. So first of all, right, we want to define a tau object because it's going to call the tau. So what happens is inside the repository, we declare a history tau object. We call it history tau. Just put small letter h. It's a property object, property object for this class, right? History tau, small letter. The data class, the class is history tau. The interface is history tau. The variable, variable is history underscore in small letter history tau. And then also we want to declare a list, which is the live data that we are going to call, get from the tau, right? The tau just now, right? Also we have a live data. So get history in the tau, we call this method. So we are going to return this value to the repository. So repository also return this value to the view model on top. So we need to declare a variable for this history tau object, history object, list object inside our repository. So this object we call it history list, or any name will do. Variable history list. We are going to get a history list and return to the view model on top. So these two, and one more, which is the history database. We need to also call the history database, right? So because let me see, to execute this first, the actual insert, actual insert. Let's say the function on the view model, right on top here. So on view model, want to execute and insert a new data into the database. So we need to execute that through the tau, right? So we need to have that backend service. We have to trigger the backend service also. Just now remember the backend service in the history room database. We have a backend service. This one, executor service. So we also want to trigger this executor service from the repository when we create. So and then execute that executor service will actually trigger the tau to insert. Like this one. Actually, it's like this one. But this is dummy data. This is inside when we create the database for the first time, then we use this executor service to execute this function, insert, only to do a dummy. But here in the repository, you want to do the real one, right? When somebody in the UI there do a QR code scan, that QR code scan will trigger the insert, insert the new string into the database. So what happens is we also need to declare this database object, so that we can actually access the executor service in the database object. So we have these three. So we import these three class, right? The one that we organize them into a package DB, right? Then we declare them first. We're going to use it, use them. Okay, so the first thing, just now I said the tau has an insert, right? Not insert. So we do the insert first. So the insert in the repository will be also a function called insert. The prototype is the same, right? The prototype is the same as the one that you do inside the. You can do the same or different, but in the interface history tau, you have a function called insert, right? But no body, right? There is no body, right? There is no body, I say, right? There is no body that implement what it should do. So what it should do, you actually execute, right? This insert query. So what we want to do now is this, we define also is a layer. So above this layer, we have a repository that we also define this method. We also define this method. Here we have a body. So it's a public method actually that can be accessed from outside of this class. Right? So here we call it insert also. You're passing a history object into this function. From above it, from the view model layer. Right? From the view model layer, you actually call this function, call the insert function, and then execute the repository insert function. So the repository insert function will continue to actually call the database executor service, the backend service, the background track. We don't do it in the UI track, so we use the database background track to execute this function, the tau function, the tau insert function. So this one, what we do is here, basically this tau is actually this object, history tau dot insert. So this insert is actually this insert. So the repository insert, the insert in the repository become the wrapper function that wrap around the tau insert function. So when you call this method in the repository, you actually call the tau insert function in the background executor service, background service, not on the UI track, but in the background track. Right? So this is how you do. And then the get, another one is the get. We want to get the history list from the backend. The backend has a function called get history and return this value. So inside the repository, you also can define a function called get history. Inside the repository, we also define a function, right, called get history. So what we do is here, we are going to this get history. We actually call the tau get history. So which is this one, right? Tau dot get history, huh? All history, get all history. This is got get all history. We call this method, right? So get all history. Huh? So you return the value of the list, this list. Huh? So we assign it to this list. Assign it to this list, and then we return this value. We get it from the tau. You go to the database, select, and then return the list of history, and then that is live data. So return that live data history, list of history to the function, the upper layer. Upper layer is whichever function inside view model that call it. Right, you return that value to the upper layer that call this function. Understand? So it's just a layer in between the tau, the database, and also the view model. The view model. Right, done. So basically, okay. I think it's better to have a constructor. I forgot about the constructor. The constructor also need. And then this value, we just return the value. Return this value. Without we don't do the tau here. We do the tau here. When we construct this repository, we get it. But actually, it can also. Actually, it doesn't matter. You can do it this way. Or if you have a constructor, right? If you have a constructor, right? That actually, okay. We pass in the application context. Application context. Application means the activity or whatever that we're running, right? So application. And then inside the constructor, we do the initialization. So initialization, you can actually do this. And do this in the initialization. Let's do it here. Right? You can do it in the initialization. When you construct the object, you straight away retrieve. Right? You can straight away retrieve the value. Right? Okay. So here, retrieve the value. Okay, here I think I forgot also. We need to actually initialize it to get the instance. The database has to be created. The instance has to be created. So what happens is we actually need to do this. Oh, sorry, I forgot. Sorry. Need to actually create the database instance. Otherwise, the database is not created. This is only the definition. This part is only the definition. Right? It's not called. This function has not been called. Right? The get instance has not been called. It's just the definition. Right? So it is called inside here repository. So what happens is this is app. This is history. Right? So we create the instance. Right? Create the object of the tau, and then only we get the history. And this history list, we return this dot history list. This property is a property of this class. We return to whatever function that call it get history. So this is when you first construct the object. Right? Constructor. This is the constructor of the repository. Right? You first create the get an instance, singleton, create the database, get the instance of the database, and then create the tau, instantiate the tau interface, create it, and then we call the get all history from the tau to retrieve the history list, and then we return from here. And then insert the other way around. We use the background track executor service to call again the same thing, same object for the tau, and then insert the object, whatever object we pass to this function, the history object, from the UI, from the layer above. Right? Okay, so this is a layer in between the database and also the view model. Okay, so let me give you. Right, so quite a lot of code. So you need to digest a bit later. Maybe you are maybe 50%, Now you cannot follow 100%, but it's fine, right? So I'll give you the sample code. So when you look at the sample code and you watch back the video, you should be able to understand, right? This is just two functions. We call it the wrapper function for insert in the tile. And this is a wrapper function. Add all history in the tile. Understand? And this is just a constructor of this class, right? History repository. It's a generic Java class. It's just a class that we define ourselves as a middle between the other two layers. All right, this is layering. In code, we try to separate the tasks of every layer, what they do, so that the UI layer will never need to call the database. UI layer also will never need to call this. Cannot. Cannot. We don't allow the UI layer to call the backend service to insert data and so on. They must go through the repository layer. So that this layer later we want to change anything. We want to plug this layer, the repository, to another type of database. Let's say we are not going to call the so-called the room. We want to connect our app, the UI, to the remote API. Then we need to change this part. And then we can remove, actually we can remove all this, all the database code, and then we can add in our code for the REST API, remote API that you have the code, right? You can use retrofit, you can use volley, where you can connect. So you can add in a volley code or retrofit code here. You can delete this one, remove all this, and then and also the database and so on. You can change it to connect to from the repository. You can change it and connect it to a remote server, a server. So you write the server code, that code to access the server here in this class. So you can actually remove your backend, change your backend easily. But now we are using this repository as a layer to connect to the room database. So if you are not using a room database, you can remove the code here, and then you write your code for accessing to the server side here in this class. Okay, I hope you understand the idea. I can show you how it is visualized. Right from the repository, you can actually change remote data source, right? Instead of model room, right? So currently we're on the left. The repository is connecting to the model, the entity history, and it's in the room database. The table is in the room database and it's actually storing data in SQLite. But sometimes you have the code already, the project done, but now you don't want to connect to the room database. You can actually easily just remove all the code in the backend, and then you just change your repository code, and then write your code that connect your app, the front end. The front end is not affected. You don't need to change the front end. You don't need to change anything on the activity and the view model. You can still connect it to another source, which is maybe through a data remote web service through, for example, REST API, right? Through then you pass a JSON to your app, right? So repository will be changed rather than the entire app, the front end. So this is the idea of doing that, using that repository layer. Okay, so now let's move on. Okay, repository layer done. Next layer up is view model. Why we call it view model? So we create a new class, Java class. We call it history view model class. History view model, not view holder, view model. Right, again, it's a generic Java class again, right? But we are going to extend, right, from some so-called the superclass, view model class, because we have this view model imported, right? So we have this dependency already, view model. So we want to extend from that view model for this history view model class. This is another layer up, right? The view model layer. Just now in this, we have the view model. We are going to do this now. The view model layer done already. This one done. This one done. Right. So here, let me add in the code. This part, right? We have just done history repository. History repository. So the next one will be can I route this here? This one. The live data. Sorry. So add in the code, add in the text first. Right, history repository. Next one will be history view model. This one. Another class about. Okay. All right. So let's close all this, all the tab, and then we just look at the history mode. Here is called main view model, but now today I'm going to use on my original code. I use main view model. But here in today's project, I use history view model. It's the same. It's just a name, different name. Okay. So now extend. We are going to extend Android view model. Extend the Android view model. View model. This is Android X class. Just import. This one life cycle. Just now I say. Okay, so this one view model class, you need to create a constructor. Right, you need to construct. Just let it do the job. Let the tool do the job for you. Right click, create constructor. So just a super, call the Android view model super, and then pass in the application, the context, application context. The constructor. Right, so this constructor. Okay, now we need to also declare, right? Because now we are doing view model is just another layer, but this layer is nearer to the activity. Just now repository is nearer to database. View model is another layer similar to repository. It's just a middle layer. It's a wrapper. It's also a wrapper, but it takes care of all the data related processing. So you can put more than just a wrapper. You can do more than just a wrapper. But for now, we just use it as a wrapper also, as a wrapper class between the repository and also the activity, the view. So we just declare another layer that we are going to access the function inside repository from here. As I said just now, it's from the top and then call the function inside the repository. In the repository, we have two functions, insert, we have get all history, right? Get all history and insert. So we are going to call from view model, right? So view model here, we're going to declare and create a repository class, repository object. And then here also same thing, we are going to return and get the history list. Again, we call it history list. History list. This history list will mirror this history list. It's the same. It's the same object. Just that we pass, we copy from the repository, copy to the version inside the view model. Later we do a copy only. Pass. So we don't copy actually. We call the method inside the history repository, which is here. Get. And then we call this insert. We pass the history object to the repository. So here in the view model now. Okay, so what we do now is when we in the constructor now, we want to initialize this. Initialize. So what we do is we just call the repository object first, create the repository object. Right, we call the repository object, create the repository object. This one. Initialize the repository object, create new. Right, pass in the application context. We can shorten it, make it add. Not just add. Okay, here. This is add. Object. Okay, so here, repository, we have a get, right? Get all history. So we call this method and return the value and assign it to this object, repository object, repository history object. Right? Just call this repository, the get all history from the repository. We execute, we call it, invoke it, and then we return. We know that this repository get history is also a wrapper. So you actually call the here the tau, the tau get all history when it is first constructed, and then you just return. This get all history will return the history list on this layer to the top, which is the view model. So view model will actually receive the history list. We receive the history list executed and queried by the repository and then executed by the tau down there. So now we also want to do the insert, the insert function. We want to define an insert here also, right? passing in the history object. Inside the view model, also we have an insert. Right, so what happens is the insert function is the same prototype. Right, it's a public. So what happens is a wrapper also, right? Wrapper. So we are just going to call the repository dot insert, right, and then pass in the object. That's all. It's a wrapper function for the insert in the repository. So this function insert will call this insert. I understand, just call it, and then pass the control down there. This is just a controller code. These are just controller code. Right, so insert. And then also get all history. We want to return the value when this view model is called from the activity, the view. So what happens is we also want to return the live data, right? The live data, the list, right? So the list to the front, to the front end. So what happens is this history list, we just return this dot history list. So when this function get all history is called from the activity, the front, the view. So the view model is just a layer in between. So if a wrapper class get all history, we actually call you actually return. We return the whatever history list you retrieve from the repository. Whatever job to be done to retrieve it from the database is up to the layer down there to do. What you do here is for this layer, the task is just to call the method, right? The method. This method is just to call to retrieve this value. And this value is retrieved from the repository layer. So quite similar to repository, it looks like similar, but this one is more to be used by, this value is going to be used by later by the activity from here, history view model. Right, done. This layer is done. So let me give you this code. This is the view model code for our example this afternoon. So this is the history view model code, the Java class. It's going to be the history view model.java class. Right, done. History view model done. So now we reach the time when we need to do something on the activity now. All the program logic will only be triggered from the UI. All the functions are defined. These are just defined. All the function constructor defined. View model defined. The functions are defined already. And defined already in the history, defined entity, defined in the file, defined in the room database. Now we need to call, right? Someone have to call. So the calling is from the front, the main activity to trigger all the action to be done in the main activity. So in the main activity, we need to populate, right, a recycler view. Remember just now, recycler view. We also have a floating action button to trigger the action to scan QR code, right? Floating action button, the ID is FAB. So now we want to trigger that scanning, right? Using the ZSyn. Just now, remember in the beginning, we actually import ZSyn to do the scanning. So this floating action button now needs to be triggered from the main activity. So what happens is we trigger that first. The main activity, we want to do the scanning first. So we need to do a so-called button listener, set on click listener. So let me copy this template. Okay, on the activity, now we want to first, how to say, bind the view first. Bind the view. So it's a floating action button, right? Floating action button. We call it FAB. We declare a floating action button, right? So this floating action button, when the app is being created, so we get the view. Right? Get the view. FAB, huh? Floating action button. We get the view, and then we declare a click listener. Click listener. We create an on click listener. So when this button FAB is on click, so we want to do something, right? On click. So what happen is we want to trigger QRCode scanner, right? Using ZSync. For this example, I use ZSync. You can use other code here, using other library. I'm going to use ZSync. So this code, I'm not going to code line by line. It's a standard code, quite using ZSync. It's called something called intent integrator. ZSync use intent integrator. It's just like intent. It create an intent, open a camera, right? When you want to scan, you need a camera. So you trigger an intent that will open the camera. That camera will actually capture the QR code. So later we can test. So what happens is we basically just need to do this standard code. I'll give you in a while. Right, basically just trigger, right, using ZSync intent integrator. So this intent integrator is running in currently is in the main activity. So this is when the button is clicked. The floating action button is clicked. This button is clicked. Right, so the action will be triggered to open the camera. Right, to open the camera, that will actually capture the QR code. These are just some settings, right, to set the QR code, the configuration. Format is QR code. We only want to capture QR code, not barcode or other code, right? So it will be a message that scan, right? So we get if the camera has more than one camera, so we tag the default camera 0. So if you put 1 we have back camera, front camera, so we tag the default camera, and then set a bit. Right, so when scan, if the scan is successful, you hear a beep sound, beep, and then barcode image enable, and then orientation is locked. So if you want to allow it to rotate, then you can set it to false. Right, so these are just some. You can check the documentation for this intent integrator, right, to check what are the format that you can configuration you can do, and then finally after configuration, then we just initiate the scan. This is the action, call to action for the integrator, right? So this is the code for you to scan. Just as simple as that. So this is the FAB, which is your floating action button. Okay, let me give you this. Do this, put this inside your on create method. On create method. Right, so how do you receive the result? You need to receive the result, right? So when you scan, so you want to receive, right? Okay, first of all, also we need to add camera support, right? I think supposedly, I think can work without this camera user's permission, but it's better to add. In the manifest file, go to your Android manifest, add in this camera permission. Go to your camera and manifest, right? Just add in this. Users permission, right? The name is Android permission.camera, capital letter. So add in this to your manifest. Add in this to your manifest. Right, so this one you add into your manifest file. Okay, now we need to have, because it's an intent, right? Remember just now we use an intent. In activity, right? Intent actually will when you want to receive the result of the intent, you need a callback, right? In Java, the callback in this case is called on activity result. It's just like you trigger an intent, normal intent, right? Also, you have this callback. If you want to receive the intent, when you go to another activity and then come back, you want to receive the value, whatever value data you pass back from the activity, the next activity that you call, then you also need to have a callback to receive that the data. It's the same, right? So here because we call intent integrator, so we also need to have a callback on activity result. to receive that so-called the data that you scan. So you return a string. Because it's a QR code, you scan, the scanner will convert the QR code to string. So you pass the string back as a data. The data will be passed back as a string. So what we do is we have to create this callback outside of your own create method. Outside. So inside your class, main activity, you create a callback method. What we do now is outside of your own create method, outside here, right? Here. So we create a back on activity result. So we need to add super call, call the super class, passing the request code, result code, and also the data. Our main concern will be the data. We're going to receive the data. So this callback will receive the data from camera, camera scan on activity result. So let's put in this class. Right, done. Okay, so now we want to write some code to receive that data. Okay, so first of all, we have to check the result code. Result code. Right, the result. So we need to receive a function to receive that result. Okay, so for this case, so if the intent result, right, we use intent integrator because we are using ZSync. ZSync. So intent integrator will pass the activity result, the callback, the activity result, the request code, the result code, and the intent, the data, history. You pass and you will actually be integrated into one result object. So that result object, first of all, we want to check the result. Is it now or not? Right? If it is not now, only we process it. Right? If it is now, nothing is passed back. If it is not now. Right? If it is not now, then what we do is we just get the content. This result object, intent result object, has a function called get contents. If the result is not now, but the content is now, meaning the scan is not successful, so we just print some log message, cancel scan or whatever. Or you inform the user with a toss. All right, you can inform the user with a toss. So basically just need to check first whether the content is now or not. Right, if it is now, then nothing can be done. So you just pass in the print a message, error message, and then ask the user to repeat again. Else, right, if the result is not now, so what happens is we can actually, okay, this one is not necessary. So what happens is, this is the most crucial part. If the result is not now, the result you scan should be a location. So make sure the QR code you scan, right, represent a location. Represent a location of the place. I call it scan location, just a variable. You receive the result dot get contents as a location string. It's a string. Let's say campus name or cafe name or a station name or whatever name. You can create that QR code to test later. That QR code should represent a place, the name of a place, which is this. Which is this one. A string that represents the location name. So here, right, we are receiving it from the ZSync QR code scanner. And then the date we don't get from the QR code. QR code shouldn't contain the date. Right? Date, scan date. Right? Scan date should get from the computer time. The font. The java.time. We use the Java utility. You can use other utility to get the current time. Right? I use Java utility for now. This one I think is I need to check because the SDK, there's a limitation to this now. So I just need to put a alias. Right. So require API, the build must be at least Oreo. Cannot be order, must be Oreo and above. So Java time. I use Java time. Utility class, it's just a utility class. Java time, where is it? No, okay, Java time, java.time dot local date, dot now. Right, if you want to time, you just put the local time, right? You just get another java.time.local time. Local time. You can get the time also. So it's up to you. This one is just up to you how to get the current day, current day date. Right, convert it to string. Right. So once the scan is successful, right, and the QR code is deciphered, decoded into a location name. So you get the location name from the QR code result and the time, the date from the current system time, computer time, right? So this one in real case, if you are doing the server side, you have a server system, remote system. This date you shouldn't get from the current phone, right? You can get it from the server code, right? This date you don't have to get it now. This date value you should get it from the server. Server side should have the server time, server date, right? Get it as the value that you store into the database. So when you store into the database, you get the current date of the server. Right? So for now, we are testing it locally only. We use room database. That's why I use it locally. Room, local time, local date. Okay, so now after these two are received, so we want to insert into database, right? We want to trigger this insert. Right? We want to insert into database, right? So how insert this history object into database, right? But this insert is in the database side. We cannot access it directly. We have to access it through history, a repository, through repository. But also we cannot, from the view model, the upper layer cannot access the activity, cannot directly access the repository, right? The history, the main activity can only access all of this through the insert function in the view model. So now we want to call the view model insert to insert it into the database. Right? This is how we do it. So what happens is now we need to create the history object. Now we need to create the history object with the current date and time. Right here. Current date and current location and current date. So we create a history object with this scan location and the scan date. Scan date. Right? Scan location, scan date. Please create a history object. And then we also need to access the view model, right? The view model insert function. So we need a view model object created. So how to create a view model object? So basically we need to here, we need to declare a object. So we go to here. It's better to declare as a global to all the function. So we declare outside, outside of the onCreate method or the function. Here, this is history view model, and this is one we call it history view model. So this history view model is the history view model that we have just created just now. This class, we want to access this insert. So here in the activity, we use this history view model to access, right? Dot insert and pass in this history object. Then it will work, right? So after we insert, right? So if you want to send a message to tell the user and so on, you can send a message and say inserted, added. But what is more important is you want to update the recycler view, right? Because recycler view, every time we insert a new object, the recycler view should be updated, right? This recycler view should see the list, right? But we haven't done the recycler view yet, right? This code, so we can actually put in the code, put in this code to update the recycler view first, but the recycler view is not done. We haven't done the view model yet. So this history list, okay, we should keep a local activity in the activity context, right? We should keep a list to keep the values of the history that we read from database. So we declare a history list, which is an array list just now, right? List. Okay, so we don't need, okay, let me see. We don't need a live data on the UI. Live data is only when it is in the backend, when there is a date change. Then you want to update the array list, right, on the UI, on the activity. So what happens is we can use any data structure as long as it's a list. May not need to be a linked list as well. You can use an array list, a list, or linked list. So we can create one list here in the activity. I use array list. Let me use array list. Just use array list. Right, so this is an array list. Now for today, we just in array list. So this array list is called history list. So this history list is the ultimate values of the database values that we read from repository, from view model, and then we populate the list on the UI. This array list. So this array list is going to be the one that we use to populate our recycler view. So this history list will be manipulated. We get the size, right? And then we add. Oh, cannot add last. Let me see. I think should be add. Okay, add. For linked list, we need to use add last, but this is add to the end. New history to the history list. Right? So we add it to the history list. This one not done yet. Recycler view. So this one we haven't declared. So we leave it now. We just comment out first. We leave it now. We haven't done it. Right? So for recycler view, right, we need to have an adapter, right? Adapter class. History list adapter. This one I think we have done already many weeks ago. In the history adapter, we need to have a view, right? To show an item that is called view holder. For recycler view, we need a view holder. And then all these are standard code. Just that for today, our history item will be something like this. So we are not going to do again. I give you this design, right? I have designed one, simple one, right? Just to show the so-called the title, which is a location name and the date. Because our history object today contain two field only, the location name and the date. So our view, the recycler view item also have these two. And then just put in some icon to make it nicer, look nicer. So this view, right? This view I can give you, right? We don't have to draw again. Basically, I've used actually use linear layout to draw. You can also use other layout, relative layout or other kinds of layout to draw, right? So I've done it for this demo. So I'll give you this. So what happens is we just need to go to our layout first to create that history item. So I right click, new layout resource file. We create a new layout resource file. We call it history layout. New layout resource file in order for us to have the recycler view. So I call history item. We call it item. Every time I use the word item for that, so that we know it's an item in the history in the recycler view. So we use linear layout. Just change it to linear layout. Right, history item. Okay. So this is an empty one. So what happens is I give you this code. You don't have to draw again. So I just right. So the drawable, the icon I give you in a while. Right, there's a drawable icon here. Later I give you. So the sample. So I give you this code. I use this. I give you the using this context. This is your layout for the recycler view item. Recycler view item. This is if you create a XML file in your layout, so it's called history item.xml. Just use a history item layout file and then you put that code in. You should get a layout that looks like this. And the icon I have downloaded. It's up for your project. You create your own icon. So for now, I use this Checkin marker.png. So for this sample, this demo, I use this. Okay, so I copy into my project. I paste it. So you can do the same. I'll give you the code, the PNG file, right? Then you'll be there. You appear here. Now you appear here as a drawable. I put it into the drawable icon. So this icon, let me give it to you. Right, this marker, huh? I give you a copy for now, so that you don't have to take the time to go and download, right, to create this quickly. You can choose a nicer icon for your project if you are doing a recycler view. Right, I give it. You can download from there. So now you should have a layout done. Layout done. Okay, let me close all the file. Right, so you should have a layout done. So now we need an adapter. We need to create an adapter. Do this. Right, this is your the item, and then recycler view just now right here. In the main activity, the layout, we have a recycler view. So now we need to do a list adapter. That code, okay, we have done a few weeks ago. Similar, the concept is similar. So that code will be, we call it history list adapter. History list adapter. Inside there, you have an inner class called history view holder. We make it static class under your history list adapter, history view holder. So it's extend from the recycler view holder. I think if you follow the class recycler view for your assignment, you should know recycler view already, right? So it's just an adapter that adapt a list of data, right? A list of history data to the recycler view, right? So the code basically there. And inside this item, history item, we have two tags. Text field. One is location, one is date. Basically, I use location and date. So in this example, only for this example, only these two text field. One is for date, one is for location. Quite simple, straightforward. Right? You just need to bind them, and then after that, for your bind, you just need to set the text. Based on the value of the location and date, you pass to your view holder. Okay, so I wouldn't code this line by line. I just give you this. You just need this to work. Okay, so what happens is we need to create this class. Create this class, new, a Java class. We call it history list adapter. Inside there is a inner class called history view holder. So let's get it in. Okay, this one need to change. So the need to change to the namespace of this project. Okay, so history class. So all done. Right, so I give you this code. You just create a history list adapter class and then put it in. This is for you to populate your recycler view. Every recycler view need an adapter. So this is done. Okay, a simple one. So I give it to you now. Right, this is history list adapter. History list adapter. You can create a new class there. History list adapter class. Java, right? So you put in this code. Okay, now the last few tasks to link the adapter to your recycler view. So on the front, we have a recycler view. Right, you have a list adapter already. So now we want to link it to this recycler view. So on the activity, what happens is on the activity, we need main activity. First, we need to declare. Just now we have done the scan, right? The scan. So now we want to populate it with a recycler view, whatever we scan. So we can declare a recycler view, right? Call it recycler view. Right? So just import this recycler view class. Recycler view class. It's an Android X. So we use the latest one, recycler view. Okay, this recycler view, we need to set the adapter, right? So that when the app is being created first time, you want to make sure the recycler view is populated with the history list. You want to get all the history list from the database. So I want to make a call to the database and retrieve all the current check-in history if there is none, then at least has one. This afternoon we have done a dummy. At least there's a dummy now. Campus cafe. Before we scan anything, there's a dummy. So this dummy we should be populated on the activity using the list adapter. Right? This should be the thing that we do. Okay, what happens is you need to first declare already. Then we want to find the view, right? So these are just some standard code. Let me just quickly do it one time. Okay, so this recycler view inside the onCreate method. All right, I think you can put it anywhere. So I think I'll put it on top, on top before the floating action button, the listener. So here. So this recycler view, I find the view, and then I create the adapter, history list adapter. And then this history list adapter, right? I create, I check whether there's an update or not. Inside the history list adapter, just now, right? There is a callback. Callback to check whether the data is there. If the recycler view already loaded, so if there is no change, then it doesn't load again. If there's a change, then there's a difference, then you update the recycler view. So that is the idea of history diff. So what happens is here in the activity, I construct a new history list adapter, and then I set the adapter, this adapter, to the recycler view. Recycler view. I set this adapter to the recycler view, and after that, I set the layout also. I want it to be linear. Vertical linear. By default, it's actually linear vertical, not horizontal, linear vertical. Right. So let's add in this recycler view. Right. Declare, and then you put this under your onCreate method. Okay. All right, I hope you can follow. You understand? So we basically now we want to adapt the data. This is just adapt, but we haven't populated the recycler view yet. So now we need to call the method under the view model, right, to receive the data. So just now we declare the data as a live data. Remember just now in the code, all of these are live data. Live data. It's an architecture component that whenever there's an update, you trigger the UI, right? So the UI, we do an observe. We do an observer to observe this live data. So you actually only update when the live data has a change. We don't want to update all the time, right? So it's actually dynamically, asynchronously updated, right? So what happens is in the main activity, we need to use our, just now the code, the code. Early on, we have a history view model, right? Created. History view model. So what happens is here, right? We need to actually create an object of this, right? History view model, right? Using something called view model provider. View model provider, right? So this is history view model. Standard code to construct your view model using view model provider, right? This is the current context, which is the activity, in the activity, and then get it from history view model. Right? So the class is history view model, which is this that we create just now. History view model dot class. So this class, we want to access what? We want to access the get all history, right? Now we want to populate it. So we call the view model get all history object function. This one. Get all history inside the view model so that you return the list to us, to the activity. So what happens is in the activity we observe. We don't directly call. We only call it later, asynchronous. This is asynchronous. So it doesn't call directly. It's called based on a callback. Only when there is a change. Observe, use the observe function. Only when there is a change. Create an observer object. Only when there is a change, callback. Only when there's a change, only we update. We use the function submit list. Submit the latest history list. Retrieve from the get all history. So this get all history will actually call the get all history here in the view model, and you return the latest history list. And this history list actually will be returned from the repository get all history, and so on and so forth down there until the database. You retrieve and pass it back, pass it all the way to the view, to the activity, and activity will actually wait for the changes, any changes, then observe. Then asynchronously, and if there's a change, any change, you'll be received as a list. Or you can call it array list also can, I think. Array list. Oh, no. This one receive a list. Should be a list. So array list can be cast to a list. So a list history is more generic. So history list. So you receive that history list and then update your adapter. So whenever you update adapter, your recycler view will display the latest list. So this is a function under your adapter. Sorry, I almost lose my voice after talking for so many hours. So more or less like that. So you need a call the get history from view model, and what view model will trickle down will actually call the other function of get all history under the other layer. So this is done. Then don't forget just now insert, right? This is done for the view, for the loading part. And for the insert, just now we comment out, right? We insert into database, right? We want to insert the QRCode scan, right? The QRCode scan. This one, insert. So we also want to update, right? We insert already, we want to update the recycle view, right? So that is reflect, you show the latest, the new location that we have just scanned. So what happens is we just need to get the adapter, notify the data set change. This function, notify get data set change. So the recycler view, the get adapter return the current adapter of the recycler view, and then we notify the changes. And then we, after notify, after changes, we scroll to the position of the place where it is updated. And we use the current size, meaning the latest one on top. So history list.size is the last record as an index. This is the index, the position. So the size is the last position. So we scroll to that position. So you, if the list is very long, right, then you scroll up to the latest record. Smooth scroll to position. This is just to miscellaneous, to make sure your recycler view doesn't show the, you don't need to scroll down to see the latest record. So notify changes and scroll, scroll to the position. Okay, I think done, right? Almost done. It should be able to be tested already, the full code. So let me give you this one as the latest main activity. This is a full code for the main activity. The last one to be done is actually the main activity. After you have done all the layer. This afternoon we have spent so much time because you need to do so many layers. So we have achieved the full spectrum of what we need to achieve for this. Okay, let me give you. This is a final code for the main activity .java, right? Main activity. So we have so far, if you recall back what we have done just now, right? View model done, right? With live data, and then finally activity, main activity. We don't use fragment, but your project, if this all happen on the fragment, then all of this you do it on the fragment code, right? The activity code be on the fragment code. You need to do a bit of modification for that. Okay, so this have summarized what we have achieved, right? Let me put it down. On the UI controller layer, we have a main activity, and then we have also a history list adapter for the purpose of recycler view. If you don't have a recycler view, then you will do it on the main activity only. Just because we have a recycler view, we need a history list adapter and a view holder. So we have that for the recycler view, right, on the layer above. Right, all done. All done. Okay, let's try out the code. Does it work or not? Run. Okay, the full code. If it works, then it should be okay. Then if your site doesn't work, have some error, then let me give you this sample. You can try it out. On, look first. Do you have any question, please? Sorry. Yeah, let the emulator load first. First build will take a while because there are so many layers. So it will take a while. And also it has to pull all the dependency in. All the dependencies. Build. Right, we have a few more minutes. Hopefully it works. I'll show you how to scan. You can, okay, before it builds, we can generate our own QR code to scan. I think you know also. Just use any generic QR code generator. I'll create one so to test, just for the purpose of testing. You can use the emulator to test. Or if you want to use your phone, you can also download the app, install the app onto your phone, and then you scan any QR code. But that QR code, you better prepare your QR code in such a way that it fulfill your purpose. I use a QR code, a generic QR code generator. So I will generate a free text, like the location name. So I just use SWM campus classroom. What is the block? I forgot already. B1 block. Let's say let's say you want to scan into B1 block. Block B1 or B1 block. This is the QR code. Yes, this is the QR code. Let me download it. Download. Right, it's a PNG image file. I download a PNG file. Block 1. Right, this one. PNG download. Right, so I downloaded it to my local drive. Right, later I want to add it into my so-called the emulator. So this is the QR code. Right, QR code done. Generated. I create one to represent SMUM block 1 B1 block. Right, so here still loading. Wow, why is so slow? Okay, it's loading. Loading. Because I shut it down just now completely. So later I will add this to the emulator. Add the QR code to the emulator so that the camera can see it inside the virtual scene. Now this is a virtual scene inside the camera of an emulator. You can test without the phone, without using a phone. See whether it's operating. Slow. Why is it so slow? I never shut it down for some time this morning until now. I should clear the cache already. Okay. It should work. Let me zip this to you in a while so that you can test it on your site. If you couldn't have the complete code, And let me give you. There are some some code that is, I think cannot zip it while it is running. I have to click it and write and give it to you. Okay, yeah, this one. So now I'm opening up the app, the emulator to configuration. This one, control, to add in some. Got already. Okay, I use the one that I just created just now. I delete this one, delete this one. Okay, so there'll be a virtual scene. There's a kitchen, there on the kitchen wall and kitchen table. I want to see the QR code so that I can scan there. So I use the one that I've just downloaded. I import it, upload it to my local folder, right? Local file. Right, edit the same to both the table and also the wall. So let me make it larger. 2. I think 2 is good enough. This one 1. Okay, never mind. Use the default size. You can use camera here. You can add virtual scene images. Your QR code, whatever you generated just now. Right, I've added. Just that the emulator is not open yet. Otherwise, you can test already. Okay, done. Build. So just the emulator is not open. Okay, let me see whether I can create another emulator. I wonder what happened today. Get another. All the while this morning was okay. Okay, let me create another one. Okay, this one. There are 4. So whatever. Okay, done already. No need. Here. Right. Okay, wait. Okay, let it load the app. Launching now. Launching. I think my computer need to restart after this class. Let me show you. I'll give you this sample code. I hope you learn something. Maybe you don't use a room database for your project, but it's also important for you to learn something called architectural component, Android X, the new way of doing all this. Even the user interface, without using room, you can also use view model and also live data. Okay, how is it so slow? Okay, launching. All right, good. Okay, done. There is a dummy, right? This is SWM Campus Cafe. This recycler view. This is a recycler view. It's actually from the dummy data. Dummy data here. This one. This one. This value is actually created in the database back end using this dummy just now, right inside the home history data room database. Right, that's why here we have a dummy. So let me click on this. Right, you bring our camera, right? If you deny, then cannot do anything, right? I use this app. Okay, let me go and scan the QR code, see whether it works or not. You can actually create the, okay, let me use, I press the shift. I think all of you know this also, right? In the virtual scene. Yeah. Okay, I go to the kitchen. Okay, I go straight. This is a kitchen. So I go. Okay, here. The QR code is on the wall. This is on the wall. Another one is on the table. Okay, let me scan. Just stop a while. Let's scan. Or maybe I move a bit to the middle. Not so sensitive. There's one more on the okay, scan. Right, see, scan already, stop. How come it's not updated? Yeah, updated. SMUM B1 block, right? Updated, today's date. Right, you can see or not, today's date, 6th of June. Right, it's update on the recycler view. And let me scan one more. Scan again, use the same QR code. Not sensitive. Come, not sensitive. Or in front a bit. Okay. Can I do something to scan it? Okay. Not so sensitive. Okay, never mind. You understand the concept. I think you can do better than me. Very hard to control my mouse. Okay, like that. How to focus it? The camera. Anyone have idea how to focus it? Doesn't trigger the scan. What is the key, shortcut key to scan? Okay. It's supposed to scan, and then you insert one more data into the database, and then you'll be shown on the recycler view. Sorry. Okay, scan already. Cancel. I cancel already. Sorry. Okay, so just to let you see how to see in the database. Okay, let's go to the device file explorer. Right, if you want to see the SQLite database, you can click on this device file explorer on the bottom right of your Android Studio. Device file explorer, data. You have to look for data, and then another data. Go to data folder. You choose your emulator that you are running, and then real time, the emulator that is running. You want to check the storage of your emulator. You go to data. Right under there, you look for your app. Your app, currently this app is called, right, QRCode check-in using room. This one, example, com.example. So look for this one. So inside the device file explorer, right, data, com.example. Let me see. Com.example, QRCode, check-in using data. Okay, database. Right, so here, history database, history underscore DB. So double click on it and then go to app inspection. Right, app inspection is down there. This is a file of your database. There are some data stored there already. So what happens is I use the app inspection down there at the bottom menu, right? Similar place where you see the build, you see the logcat, profiler, and app inspector. Now it'll take a while to load, right? It'll take a while to load. Select the process, right? It'll take a while. You load the app that you are running. Currently the emulator. So let us just, how come mine is not working? Okay, let me just double click the database again. Right, yes, it is supposed to be loaded here in the app inspection. It's not linked here. No device detected. I think my emulator is not detected. Okay, let me check again. Double click on this one. Let me synchronize. Okay, so go to app inspection. Okay, supposed to work very easily. Okay, never mind. Let me close this app for now, for a while. Close it. Right, I go to the app and click on it again. Right, the app is still there, the data is still there, right? Too, right? It's permanently stored right inside the database. Go here, application. How to trigger it? Okay, it should work. Supposedly should work. For your case, you can just select this app inspection here. You show your app. This app com.example.qrcode. Right. So this app, you select that app, you can see the database will be loaded. Right, and then you see the table. You double click on the table name. Then you can see the record. Right, the record that you have scanned. To do this. Okay, my Android Studio needs to be restarted already. Something is wrong. Let's see. Right, this is the file, database file, but you cannot see it. This is binary. So you need to open it using the app inspection to see the database schema, right, and also the database data. Let me synchronize. Okay, never mind. So in the next class, I will show you. You can check on app inspection. You just click on device file explorer, and then you click on app inspection, right at the bottom. Right, you should be able to see here. Select process. Allow you to select which emulator or which device that you are running. Currently, the running one is my Pixel 5 API, my emulator. So you should be able to select the emulator and see the database. So this is how you check your database table. Right? Okay. So any question for this, for room database? So to summarize it, we basically have done the whole process of creating this using the Android X Jetpack architecture component, which include room, which include repository, which include view model and live data. All this together. It's a framework that put under one. So that is easier for you. Next time you want to add additional table, you want to add additional function. You want to add additional function, you just need to add here to your tile, and correspondingly to your repository, you just add function here. Whatever function you want to use to manipulate your database, read database or insert database or update database or delete database, whatever you can do. And then on your UI, very few code that you need to change, except maybe the place where you want to call the function through your view model. So you just link all together in multiple layers. So this is what you can do using the Android X framework. Okay, so that's all for today. I will give you this sample code. You can try to run again and then understand how it works. Okay, let me just clean the project. Clean the project first. Right, let me clean it first before I send you a copy. Okay, done. So let me give you a copy. Okay, this one, I give you a copy. Okay, thank you for attending the class on a public holiday in Malaysia for the university. So next week I'll see you again on Monday again. On a Monday, we'll continue with week 12. Today is already week 11. So we try our best to finish all we can. That we can, I think can help you with your assignment. But I think many of you are doing very well. You have already moved ahead of the class. You can explore what you want to do. Anything you want to inquire on how to implement that you don't know how to implement, you can always inquire me. But these are standard way that they're quite general. If you follow all this, you should be able to do most of the function that you want with a database at the back. This is for local database. We are going to try to use retrofit again in the coming week. Try to do the same, but the data is from the server side. Okay, if you have any question, please ask. Do you have any question? Okay, we have finished the 3 hours. If you have no question, then I'll see you again next Monday. Next Monday will be 13, right? 13th of June, right? 7天，7加6 13，对。 13th of June, Monday, same time, 3 to 6 p.m. in the afternoon. Right, the recording I'll put online,